Okay, so magnesium carbonate's got this formula and it gives some information about the ions, and it's telling us that the atomic number for magnesium is 12. Give the electron configuration for the ion. So let's just work on this 12 for the atom. If we have 12 electrons, they are arranged 2, 8, 2. That's not stable. So to form an ion, it will lose those 2. So that means that the ion has an arrangement of 2, 8, and hopefully that is one of the options, and it's option B. Explain why solid magnesium carbonate cannot conduct electricity, but magnesium can. Okay, so let's break this question into two parts. So here we've got magnesium carbonate. So magnesium carbonate is an ionic substance. And that means that the ions are held in a lattice and are not free to move. So we can say the ions are held in a lattice and are not free to move. In terms of magnesium, magnesium is a metal and contains delocalized electrons, and those delocalized electrons we always say which are free to move. So in terms of marks, that part is worth 2 and that part is worth 1. Okay, next little bit, calculate the percentage by mass of magnesium. Okay, so to do this, what we want the percentage of magnesium. So we want to know how much magnesium there is in the formula, and then we want to know the mass of the whole formula, and we times that by 100. So in this formula is 1 magnesium. Magnesium has got a mass of 24. In the formula, we have got that 1 magnesium plus a carbon, which is 12, plus oxygen, which is 16, but there are 3 of them. Okay, so that's what we've got there. So let's plug that into my calculator. So 24 divided by, then we're going to put the other numbers in, 24 plus 12 plus 3 times 16. And we'll do that, and then we're going to multiply that whole thing by 100 to get a percentage. And here we have got an answer of 28.6 if I round it up to 1 decimal place, and that is a percentage. Okay, the final question, and it's the 6 marker. I always like to try and think how I'm going to approach this before I set off doing it. I think it's a good idea to have a strategy. So we're given some information. This student's reacting magnesium carbonate and magnesium with the sulfuric acid. And the question says, first thing we've got to do is explain what we would see. So what we're going to see in the test tubes. And then explain, the second part is give the tests that they're going to do to identify any gas. And there is a third part to this, which is include word equations. So give a word equation for the reaction. So I've got 3 parts. I'm going to do that for magnesium, and then I'm going to do the same thing for the magnesium carbonate. So let's go through this as an answer. I've actually done the answer, so I can just talk through it. Sometimes it's easier to do that than be writing at the same time. So first off, my equation for this reaction, the knowledge I need to know is that this here is the general equation. So if I take a metal carbonate and add it to an acid, I get a salt, a metal salt. I also produce water, and because it's a carbonate, I get carbon dioxide gas produced as well. So if we know this general equation and we write that down, we get a mark for that, then we are able to then write the proper equation. So in this example, the metal carbonate is magnesium carbonate, the acid is sulfuric acid, And because it's sulfuric acid, it's going to make a sulfate. So we've got magnesium sulfate plus water plus carbon dioxide. What would we see happening was that second stage? Well, what we'd see happening this would be reacting, and as it reacts, it's going to start to fizz because it's making a gas. There's my gas. So we see bubbles, we see fizzing. This will start to disappear as it reacts. So this, we put it in, it starts to react. We won't see it anymore. So this is going to start to disappear. We then start to get the gas being produced, and the gas is carbon dioxide. How do we know it's carbon dioxide? We've got to identify it. We would bubble that gas through lime water, and the lime water will turn cloudy if it's going to be carbon dioxide. So the bullet points with these two equations is what we need to include for that part of the question. Now let's look at the magnesium. I'm going to start over here. So if we take a metal with an acid, metal and acid makes a metal salt, and we also get hydrogen gas being produced. Turn that into the real equation using the chemicals that we've been told. So we've got our metal is magnesium, the acid is sulfuric acid. So again, the salt is going to be magnesium sulfate with hydrogen gas being released. Because this reaction makes hydrogen, we will see bubbling and fizzing as the gas is produced. This metal would disappear again, so we drop it in and it starts to react and disappear, and the hydrogen gas is being produced as that takes place. How do we show the gas is hydrogen? We'd collect the gas, we'd put a lit splint inside the gas, and it would burn with a squeaky pop. In terms of marks, you get marks for the quality of your writing and your spelling and your use of scientific terminology, but we've got to make sure we fill this full of knowledge. So there are 14 bullet points in this answer I've just given you. So if you're getting kind of 12 to 14, give yourself 6 marks, and 9 to 11, 5 marks, and so on and so on and so on. Just fill it full of lots of knowledge to make sure you secure the best marks possible on that particular question.